Hey, 8th graders, I just wanted to go through this data that we got from Carroll College the other day so you guys understand how to read the graph. So when you guys are asked to incorporate some of this data into your sunscreen lab as part of your either PSA or your commercial, you guys know how to read it properly and know how to take that data and use it. Okay, so your learning targets, I can identify UVA, UVB, visible light based on the wavelength, and I can interpret a graph to determine the percentage of UVA, UVB, and visible light that were not filtered out by the sunscreen. So that's kind of going to be what the graphs show us, is how much or what percentage of light is not filtered out when we use sunscreen. Okay, so remember the wavelength determines the type of light. The wavelength is the distance from peak of one wave to the peak of the next wave. The longer the wavelength you have, it's going to be further distance between peaks. Okay, and that's going to kind of represent less energy that the wave is carrying. Okay, whereas we go shorter wavelength, we're going to have a lot more little waves in that area. Okay, and that's going to kind of show us that we have a lot more energy being carried. So the longer the wavelength, the further the distance between peaks, and the lower the energy of the wave. Okay, the shorter the wavelength, the shorter the distance between peaks, and the higher the energy. Okay, so as our numbers and measurement in nanometers get smaller and smaller, okay, that's going to be a shorter wavelength and therefore higher energy. Okay, as our numbers get bigger and bigger on that scale in nanometers, that's going to be a lower energy wave that has really long wavelengths. Okay, all right. For the visible light spectrum, some of the numbers that you guys need to know as far as measurement of wavelengths. Okay, visible light, so that would be like any light that you guys can see, colors of the rainbows. If we were to take and shoot that light through a prism and break it into its different energy levels or its wavelengths, you guys would see that ranging from 380 nanometers to 750 nanometers. Okay, so that's all visible light. Again, that's your colors of the rainbow, Roy G. Biv. Okay. Other wavelengths that you guys are looking at in this lab is obviously UVA light is 315 to 400 nanometers. Okay, so there's a little bit of overlapping here in our higher energy part of our visible light spectrum. So that's UVA light. Okay, UVB light is 280 to 315. So again, that's a little bit lower energy, or excuse me, higher energy, lower wavelength. So obviously UVB has a little bit more energy. And then one that we really haven't talked about a ton is UVC. That goes from 200 to 280. Okay, there's also a range between about 100 and 200. That's like a UVV, like a vacuum. I don't really know a ton about that one, but this one's going to be our highest energy out of the three. Okay, this is definitely super harmful to cells. That's why we would use it in disinfecting. So in the corner of my room, I have a goggle disinfectant, and the light that they use in that is UVC to kind of kill any bacteria or viruses that might be on your guys' goggles. Okay, so UVC is extremely harmful and is used as a light disinfectant. UVC is filtered out by our atmosphere, so it does not reach the Earth's surface. So we don't have to worry about protecting ourselves against UVC. Okay, here's just kind of a visible light spectrum. Here's this range of UVC right here. This is the UV vacuum. Okay, this is UVB, is 280 to 315, 315 to 400 is UVA, and then starting here we have 400 to about 700, 780 is going to be our visible, and then after that we have infrared. So this is going to be our lower energy, this is going to be our higher energy, and this, of course, isn't showing us like gamma rays or X-rays or radio waves, whatever the case is. Okay, so this is the data you guys have. I'm going to go through like 3 or 4 examples for you guys and show you guys. One of the first things we tested was a pair of reading glasses. Reading glasses are supposed to filter out UVA and UVB light, but obviously we want regular light to kind of still hit our eyes so we can see and read properly. Okay, on the x-axis of these graphs, the blue line shows the UV light. Okay, so I kind of highlighted your range of UVB light right there in the blue. Okay, the yellow is going to be UVA. So we've got from about 315 to 400, and then from 400 on we have visible light. So you can see then our y-axis shows us the percentage. When you guys are looking at these graphs, be sure to pay attention to the y-axis because it's going to be different every time. You're not going to see the same 0 to 10 scale or anything like that. You guys want to pay attention because your scale might be different every time. Okay, so we got 0, 2, 4, 6, 8, 10 in this case. This is going to show us the percentage of light that actually made it through the sunscreen, or excuse me, through the glasses. So in this case, our line is pretty flat, right at 0%. Okay, up until about, looks like 350, 60, 70, 75 maybe, about 375 for our nanometers. or wavelength, and then after that we start to increase the amount of light that's able to get through. So it looks like just a very little bit of UVA gets through those glasses, but for what we see of the UVB and most of the UVA, 0% of that is getting through, okay? 100% is being filtered out, okay? Even with these glasses, we have a little bit of visible light being filtered out as well, okay? So it looks like it's kind of selecting a certain color to filter out, which might be helpful for people who get like headaches and stuff like that if they get certain light hitting their eyes, okay? Here's a pair of sunglasses just to give you guys a reference. So again, about 100% looks like all of UVB and all of UVA are filtered out. And then obviously the purpose of sunglasses is to kind of dim the light that's coming into your eyes. So if you guys look, again, our y-axis is a little bit different here. We go by 10s, 20s, 30s. Okay, it looks like it's filtering out almost 80% of the visible light. Okay, so only 20% of visible light's hitting your eyes, which is desirable for sunglasses. That's what you want. Okay, next one, again, we've got blue is our UVB, yellow is our UVA, and the green is the visible light. This is a sunscreen. Okay, it's kind of hard to see. I kind of covered up the y-axis here, but this notch right here is 80, 70, 60, 50, 40, 30, 20, and 10. So it looks like less than 10% of our UVA is getting through. I'm going to guess this sunscreen's probably a little bit expired. Okay, so less than 10% of our UVB is getting through. It looks like anywhere from 10% to maybe 20%. Most of our UVA is being blocked, except for about 20% at the most. And then there's this little blurb here, right here, that has a little bit more UVA getting pushed through up until almost 80. So most of our visible light is getting through on that, which is fine. Okay, so those are 3 examples to you. The other ones you guys are going to look at are, here's your lotion. It's the Banana Boat Sport Ultra, so you guys can see kind of how that filters out. I marked out, here's your UVB, here's your UVA, and then anything from here on out is going to be visible light. Okay, you guys can kind of see how ineffective like a 4 SPF is. Okay, when we're looking at this, my numbers start at 70, okay, and they go up to 90. So again, pay attention to your y-axis there. It looks like only 70% of UVB is being blocked. Or excuse me, only 30% of UVB is being blocked. 70% is reaching your skin. Okay, so that's about to right here. And then looks like there's a little bit more UVA being blocked, but not very much. Okay, so keep that in mind. That's how you guys read those charts. If you guys have any questions, let me know, and I'll talk.